Welcome to the Design Master Electrical RT video tutorial series. The first video in this series will show you how to start a new project, modify panels and other distribution equipment, manage branch circuit devices, perform fault and voltage drop calculations, and update the project customization. The second video will show you how to generate a one-line diagram in AutoCAD based on your project. If you'd like to follow along, links to the written tutorial and project files can be found at the bottom of this page. Let's get started. Before we start working in Revit, let's set up the AutoCAD portion of the project using the Start New Electrical RT Project command. Here, you can name the project and see where the project database file will be created. You can also select a standards database, which is used to import predefined customizations. For now, we'll press the OK button to use the default settings. This will create a .dm file in the same folder as the current drawing. Additional drawings saved to this folder will use the same database. This means the information in your Revit project will be shared across all drawings in the folder. If you move the drawings to a new location, you must move the .dm file as well. This tutorial uses the Sample Systems project provided by Revit. This project may be listed on the Recent Files screen. If not, you can access this project by going to File, Open, and Sample Files, then opening the file. This file is read-only, so we then need to use Save As to create a separate version of the project. We'll save this in the same folder as the other tutorial files. Now that we've set up our project, we can start making modifications. In Design Master Electrical RT, devices that distribute power, such as panels, switchboards, and transformers, are collectively referred to as distribution equipment. This tutorial only works with the devices in this project, but the concepts carry over to other devices. Select the service transformer and run the panel edit command. When Design Master is added to an existing project, values such as the device name, voltage, and frame size are pulled from Revit and must be reviewed for accuracy. Set the transformer kVA to 600. Under Fault Calculations, set the utility fault to Fixed and 65,000. If the device closest to the utility does not have a fault value set, an infinitely high number will be used. Select the switchboard from the list and set the bus amps to 400, main disconnect type to breaker, and frame size to 500. Next, select MDP3. Set the bus amps to 200 and the main disconnect type to breaker. Then press the Exit button to close the dialog box. You can also make changes to distribution equipment at the family level. Select the service transformer and run the Edit Family command to open the family file. Run the Family Edit command. The values you can set in the family are determined by the device type. Set this to Distribution Equipment Transformer. The upper portion of the dialog box is used to set values for the entire family. The lower portion allows you to set values for specific types within the family, such as those for different kVA ratings. Find the 300 kVA type and set Override Family Values to Yes. Set the upstream description suffix to -300 and the kVA to 300. Enter similar values for the 500 kVA type and press the OK button. Once the changes have been made, we need to load the updated family into the project. If you save the family edit values will carry over if you use this family in future projects. They will still be loaded into the current project if you don't save. We'll select No for now. When overriding the family, make sure you overwrite the parameter values. Now, if we select the service transformer, change its type to 300 kVA, and run the panel edit command. The description in upstream equipment and transformer kVA have been updated to the family values. Exit the dialog box, change the type to 500 kVA, and run the command again to see how the values change. Similar to the way Design Master refers to power distribution devices as distribution equipment, and devices such as mechanical equipment and receptacles are referred to as branch circuit devices. For this tutorial, we'll be working in the default 3D view on this cooling tower. Select it and run the circuit edit command. Here, you can make changes to the circuited devices in your project. As with distribution equipment, existing projects will have some of the values populated, and they will need to be checked for accuracy. Clear the description replacement. Set the breaker trip size to size automatically, and the frame size to same as trip. Press the Exit button to close the dialog box. You can also make changes to branch circuit devices using the Instance Edit command. This can be helpful for devices that have not yet been circuited. Set Override Circuit Description to Yes, and enter C Tower. Set the breaker size to 100, the wire size to size based upon breaker, and press the OK button. You can select the cooling tower and run the Circuit Edit command to see how the values change. Your typical workflow in Revit may involve changing devices through the panel schedules. Unfortunately, this method does not work with Design Master, as the panel schedule values are overwritten by those set using our commands. If we change the circuit description to cooling tower, and the trip to 70. Then bring up the cooling tower in the Circuit Edit dialog box. You will see that the values have not changed. These are the values that will appear when you go back to the panel schedule. To demonstrate how you can make changes to branch circuit devices at the family level, we'll use the AC unit family in the tutorial files. Run the Family Edit command. Set the device type to Equipment Connection. Notice how the available settings change depending on the type. Set Show on One-Line Diagram to Yes. MOCP to 40. Breaker size to motor compressor and less than MOCP. And wire size to size based upon loads. Press the OK button, then save and close the family. Now, we'll load the family using the Revit Mechanical Equipment command, followed by the Load Family command. Select the AC unit family. Place it somewhere on the model, and circuit it to panel CTP. If we select the unit and run the Instance Edit command, the values set in the family have carried over. Set Override Circuit Description to Yes, and enter ACU. Set the breaker size to 70 and press the OK button to close the dialog box. Run the Circuit Edit command to see how the values set in the instance override the values for the family. When you finish drafting your electrical model, you can calculate fault, voltage drop, wire sizing, and more using the Calculate commands. The first, Calculate Whole Project, is the most thorough and takes the longest to perform. Once the calculation is finished, run the Fault Schedule command. This schedule works the same way as any other Revit schedule. To modify the information displayed, run the Insert command. Remove the short circuit rating field. Then add the panel bus amps and panel distribution system fields. Shared parameters for Design Master always start with DME. Press the OK button to update the schedule. Next, we'll run the Voltage Drop Schedule command. The voltage drop is very high for some devices. This is partly due to how transformer voltage drop is being calculated. You can modify this using the Customization Options command. This dialog box allows you to set options for various aspects of the project, such as default calculation methods and values. For the transformer voltage drop calculation method, you have three options. Voltage drop is calculated as normal, transformers are ignored, or voltage drop is reset to 0 at transformers. Select the Ignore option and press the OK button. Run the Calculate Whole Project command again, and notice how the values change. Sometimes you'll make small changes to your model that don't require recalculation across the whole project. Run the Panel Edit command. Select panel LP3B and set the bus amps to 60. Do the same for MP3B. For transformer TP3A, set the kVA to 150. Then press the Exit button. Go to the Fault Schedule. You can do this with the sidebar or by running the Fault Schedule command. Now run the Calculate Part of Project command. Here you can select which part of your model to perform calculations on. Only the device you select and its downstream connections will be calculated. Select panel MDP3 and press the Calculate button. When the calculation finishes, the fault schedule will update to show the new values. With Design Master, you can set wires to size automatically based upon the ampacity of the device. To customize which wires are used, run the Wire Ampacities command. This dialog box allows you to set the wire size used for each ampacity, the conduit material, the types of devices that should be fed by those wire sizes, and more. One common customization is to change the wire size for 400 amps from one run of 600 kc mil to 2 runs of 3/0. Make sure you change the X and R values accordingly. Set the service ground wire to number 4 and the equipment ground to number 6. Then press the Exit button to close the dialog box. Run the Panel Edit command and select the switchboard to see how the wire sizes have changed. The changes made to your customization can be saved for future projects. If you customize a project template file, any projects created using that template will use your customization. You can also use the customization export command. Name and save the file. You can then run the customization import command on future projects and select that file to load your customization. This concludes part 1 of the Electrical RT video tutorial series. In the next video, we'll cover generating a one-line diagram in AutoCAD.